Here's another video presentation from Electronics Engineering graduating batch of 2016. I'm Engineer Roselito Tolentino and I hope you enjoy watching this video.
Hi, I'm Archie.
I'm Lem.
I'm Dale.
I'm Dexter.
I'm Dan. We are the representative of Polytechnic University of the Philippines, Santa Rosa campus.
We are here to present our thesis study under the supervision and advisory of Engineer Roselito E. Tolentino.
Our study is entitled
Application of Microsoft Xbox One for Mimicking Robotic Kris with 3 degrees of freedom in different poses.
Humanoid robotics is an emerging and challenging research field, which has received significant attention during the past years and will continue to play a central role in robotics research and in many applications of the 21st century. Humanoid robots can either mimic the whole human body parts or just a part of it. Most common body parts that were chosen are arm, leg, and shoulder. Wrist is the least chosen part of the body to be mimicked, since it is very intricate. Past studies about robotic wrist mimicking always use wearable gloves as its controller. Wearable gloves have either potentiometer or accelerometer or any other sensor that can be used to send data from the wrist movement to the hardware. A recent study entitled Application of Kinect for Windows using Near Mode in controlling the robotic wrist movement, wherein the proponents used Microsoft Kinect for Windows as camera sensor and its function called Near Mode. By using Near Mode, the proponents were able to detect the object in front of the camera sensor for as close as 50 centimeters without losing accuracy or precision, with a graceful degradation down to 40 centimeters. With the use of the Near Mode, the study becomes static, wherein the user placed their arm on a platform, which leads the project not to mimic the roll motion. The proponents will solve this problem by using Microsoft Kinect for Xbox One. Xbox One sensor is the updated version of Kinect 360. From 20 joints, it can now detect 25 joints. With the use of the additional points, which is the thumb and index, and using the concept of vector cross product, the proponents use the thumb and index as basis to create 3 imaginary vectors that enables the user to move his hand freely and allows the user to create roll motion. Then by using the concept of vector dot product, they are able to get the angles of the human wrist movements. The Kinect will first capture human wrist movements of the right hand of a user. Then, the proponents use the concept of skeletal tracking through C# language in Microsoft Visual Studio and use the skeletal data and depth data to get the coordinates of 5 joints, which are the elbow, wrist, thumb, index finger, and shoulder. The proponents use the concept of vector sum to create vectors from the wrist joint to the thumb, index, elbow, and shoulder, and then use the vector cross product to create 3 imaginary vectors. The proponents are able to integrate the raw tracking and compute the pronation, supination, flexion, extension, radial deviation, and ulnar deviation of the human wrist using the concept of vector dot product and send this data to the microcontroller, the Arduino. This will control the movement of the servo motors for the robotic wrist to achieve the mimicking of the movement of the human wrist. The proponents created a robotic wrist prototype. The main material that was used is aluminum so that the weight of the prototype is light that can be handled by a low-torque servo motors for the movements. The proponents used LabVIEW software to simulate and to evaluate the data gathered. Communication between LabVIEW and Arduino is possible through LabVIEW Interface for Arduino or LIFA. LabVIEW Interface for Arduino Toolkit allows developers to acquire data from the Arduino microcontroller and process it in the LabVIEW Integrated Development Environment.